So a lot of you have asked, heat, not so heat, with your LEDs. We're going to find out more tonight. Good evening, ladies and gentlemen. It is another lighting chat night, and we have got the one and only Nick Airriess with us this evening. Good evening, Nick.
Good evening, John. How you doing today, man?
Hey, doing well, doing well. Summer's over. It's time for us to get back into doing what we do best, which is talking nonsense. Oh, wait, I mean talking about lighting.
Yeah, there you go. There you go. Gotta have content. Gotta content.
Content. That's right. That's right. And tonight I wanted to jump into a question that I've actually had this one. It was sent to me, and then at DJ Expo, a gentleman was looking at some lights, and he asked a question about it. And the question is, and I knew you were the guy who could answer this for us, is the importance of keeping your LEDs cool. Can heat cause damage to our LED lights, in ways that are similar or maybe slightly different, but related to how it works with our incandescent bulbs? So, heat, LEDs, take it away.
Sure. So heat can be a problem. You don't think about that though. When you think about LEDs, you think about low heat, low energy,
right.
low power. I mean, if you're talking about actual power output, LEDs use a lot less than a standard incandescent bulb, even than you're just things you see in your house. You see all these things at hardware stores and advertising that it must be cheaper to add these in, but you still have to get rid of heat somehow, because eventually you get enough power in one little spot and it creates a lot of heat. So what I wanted to do is actually start out with what a lot of people think LEDs are, and this is probably the biggest thing in people's memory right here.
Yep.
It's the standard 10mm LED. This is actually a 1/4 watt LED. Some of them are even 1/2 watt, so that's the amount of power that you're putting into them. Now this guy is actually on a fiber circuit board, so you really don't have to worry about a lot of heat with these, because they are only a 1/4 watt, and they're pretty self-contained. You've got the optics all inside them and everything, and they're pretty much ready to go right in the package. So they fire a beam of light out, but they don't create a whole lot of heat. That's why they can use a fiber board to create the circuit board for this thing and do all the circuitry and all the wiring and everything, and just have this total package here in one little thing. But as we wanted to get, one of the big downsides about these is color blending. You're not going to be able to get good color blending. It just isn't a very good LED. From efficiency standpoint and not creating heat, it's a great LED. It puts out a lot of power while not using a lot of power. That's why originally the first battery-powered lights had 5mm and 10mm LEDs like this, because they were just super efficient.
Sure.
And yeah, they didn't waste a lot of energy and heat. And that's what heat kind of is. It is a very wasteful output of energy. So the next kind of level up from that is your standard surface mount or SMD LEDs, and I actually have a little circuit board here off of a product. And what this guy is this guy actually has these little LEDs mounted on here.
Okay.
And this board is actually, it's metal. So what they're using to get the heat away from that LED so they can make it brighter and make it put more power out is they're using the actual circuit board that it's mounted to diffuse the heat, which is really cool, because then they don't have to build all this extra stuff behind it and everything. But what people found out though is that as they crank the brightness of this LED up, they really need some other type of cooling to really get that heat out. If you look at your lamps that you see at Home Depot or whatever that you use for a replacement lamp, most of those have a pretty nice cooling system in them. You can see a lot of fans and fins and stuff in there, because most of those you can't really make a lot of noise. They've got to be pretty quiet, so they need a lot more surface. And so this is where I kind of wanted to go with this, is there are really 3 different ways to remove heat from an LED, especially because it's such a small little space right there. You've got to get that heat away from it, and it's very concentrated, so you've kind of got to spread that out and get it out of there. The most common way is to use a fan. They have a little a grill behind it, or like a little metal kind of setup back in the background here that actually removes the heat. It gives a lot of surface area on the metal, so it allows the heat to go into the metal and then disperse out. Now you can kind of supercharge that heat getting off of the LED board by having a fan blowing on it. It's just like, you're sitting in a chair on a hot day and you want to have the fan blowing on you and just get the heat off you.
Right.
It's the same thing that's happening with the LED. The problem with that is the fan makes noise. I don't really care how, no matter what, a fan will make noise. If it doesn't make it when it's brand new, it will make it later once it's gummed up with a bunch of stuff. It's going to happen. It will. So the reality is that the best way to go is fanless. This actually uses the entire housing of the product to as a heatsink. So it's funny because you'll put a light up. Let's say you're using it in an install environment, and you put a light up into the ceiling, and you're having it point down onto something, and you go up and you're like, you know what, I have to make an adjustment after it's been running for a few hours. You touch it, it's like it's hot to the touch.
Right.
That's the heat getting wicked away from that LED, getting removed and keeping it safe. The problem with not using a fan is you have to be really, really good at figuring out how much heat comes off the LED at full brightness and how much like actual surface area you need on the outside of the product to be able to disperse all that heat. Now, most electronics, especially when it comes to lighting, they have already figured out a lot of that heat dispersion stuff. With a fan, they have an automatic. Normally, they have like a software in there that will control the fan speed based on what the actual LED output is. So if it's out putting out a lot of light and you have all 4 colors on full white, just booking as much brightness as possibly can go, then you'll have the software will automatically turn the fan up. And then when it's not on, or if you have all the LEDs off, it shuts the fan off and doesn't waste that, make that noise or whatever. It's actually that's a big point of debate with a lot of lighting guys that I talk to, whether to have fan control or fan on or off, or just a constant fan, because it's this whole idea of where if you get used to the noise and you walk into a room with the noise, you don't even hear it. It's kind of funky. There's if you have like a big barn fan going in a room, you don't even hear it if you walk in. But if you walk in the room and then you hear them turn it on, then of course you hear it.
Yep.
So it's kind of a trick. But the cool thing though is with the fans, you can actually have DMX control of the fan to have it turn it on or off. But normally they have an overriding system that will protect the LED from getting too hot. And actually, a lot of these boards will have a secondary temperature sensor on the outside that'll make sure that this board stays a specific temperature and won't let the LEDs overheat. And if they do get above a certain temperature, they'll shut off. And in fact, when you use the convective cooling, or what we were talking about with no fan, that has a system in there that actually dulls down the LED brightness to make sure that it doesn't burn out the LED. So if it gets above a certain temperature, the actual LED brightness will be stepped down so that it doesn't overheat the unit. I mean, it takes a lot to really overheat these LEDs. I mean, they're soldered in place, so they can clearly take a little bit of heat, but it's not really it's not really a worry. Most good LED fixtures, like from any of the big name companies, they will have software built in like that'll allow you to protect your LEDs and not have to worry about it. Now, this is one thing you got to worry about, is that if you buy stuff direct from China, whatever, you don't know if they've actually put in the time to make sure that the cooling is good in these LEDs. That's something that a lot of good companies do.
Yeah.
So there's one more type of cooling, and this is my big interest right now. I, of course, love computers also. I love to work with computers, and one of the big things in computers right now is liquid cooling.
Yeah.
They use that to really get the heat quickly off of the LED and put it into a larger heat sink that may be remote from the LED. I have a really cool example of it. Let me grab it here really quick.
Sure.
All right. This bad boy right here is called the G-Max 150. It's from Blizzard Lighting. And if you look, there's this massive, let me just get this thing set here. I'll turn the screen down a little bit. So if you look, there's this massive cooling thing right here. This is the actual liquid cooling system that cools the LED down. So you've got the actual LED mounted up like right here. You can actually see the 2 big wires that go into it right here, these massive cables that put a whole bunch of power to it.
Okay.
And this is a 150 watt LED, so it's very, very bright. And very, it makes a lot of heat. And so you can see these 2 coils that go from the actual surface of the LED, and then it goes around and then to the actual heat sink. So what this does is this really wicks the heat away from the actual LED surface itself, and it really gets a lot of the heat off of there. And this, of course, is a temperature controlled fan. So based on the actual temperature that it reads, it will change the fan speed and adjust. This is one of those moments where you want to bring up cleaning. This is a very clean fixture and very pretty fixture. the problem that can happen is there's this little fan right here. This
Yeah.
is actually what cools the liquid cooling array here, the actual, like, where the heat comes out, gets removed. It's really important to keep this fan clear and clean, otherwise it won't be moving air in there, and it can really it can cause havoc in your system, because what will happen is your cooling system or your software in here will try and cool the LED, but it just can't, so it'll crank the fan up even more and more and more, and then eventually you'll get to a point where, because it's a good fixture, it has a software program in it to shut the LED off to make sure that it doesn't damage it. And so a lot of the times when you have a problem with a fixture, you'll actually have a perfectly fine fixture. It might be just that the fan's dirty, or it might be that just that the temperature sensor's bad, or something like that, that's not really associated with the actual, like, LED output, but it could be causing a secondary issue. So that's always something to look for if you service your fixture yourself, which I know a lot of guys do. And then the final type of cooling, which is more future, I like to give you a little peek into the future of where things are going to go. I'm not saying that anybody's doing this yet, because I don't think that there's enough efficiency out there yet. But something called a Peltier device. It's a not USB, but like a 5 to 12 volt circuit, like a chip, that actually has, when you apply current to it, it has a hot side and a cold side. And it actually moves energy through it, so that you actually get, it's like a mini air conditioner. If you ever had one of those little USB fridges that you have in your in your car or something like that, that has a Peltier device in there, because they can't afford to have an actual, like, cyclical cooling system in there like a normal air conditioner. So they have this little circuit that's very efficient, and it has a cold section and a warm section, and you separate them by like a barrier. And then you have fans over here, and you have the cool part over here. And this is really exciting for LED technology, because this means that you can direct the actual cooling of the LED or whatever to, like, right where you want it. So that means you can really overdrive LEDs. I mean, we're seeing right now as commonplace 50 watt, 60 watt RGBW LEDs. I mean, that's a heck of a lot of heat generated by just that little LED in that little tiny spot. I mean, you're talking about something that's smaller than a dime's width that's producing 60 watts of LED power. That's crazy. So a lot of those are actually on, like, a copper, brass, or even aluminum plate that they're soldered to, and all the circuitry is laid out there, and that's what transmits the heat to the actual cooling system. But they still got to remove that heat and get it out of there. So that's really exciting to me, because I know eventually that's going to be incorporated into something, and then we're going to have a very, very powerful LED fixture. So I know it was a lot of stuff. Did it all kind of?
No, it did. It just made me kind of think back to the days of when we had our big par cans we used to use when we do lighting for bands, and we'd have a 500 watt sealed beam light in there. And I'm thinking to myself, I don't even know if we really worried too much, besides not to touch it when it was on. But I don't know if we worried too much about heat. I mean, we just knew they get hot. You don't put something above it, and
what's funny is that one of the things that people don't think about is like I did a venue out here in Madison where we switched over 32 original 575 par cans over, and that's 32 par cans. That's 32 575 watt heaters in that room. And in the summer, you really notice that when you have to get the air conditioning going in there, because now they barely run it when no one's in there. Obviously when people are in there, you've got a bunch of heaters walking around, but the amount of heat that comes off of an equivalent LED fixture is still not anywhere near the amount that comes off of that.
Yeah.
And not to mention, a lot of guys want to be packed up and out of there at the end of the night. You can't just immediately go with a 575. You got to power it down, let it cool, and then you can put it in a container or something, and you still have to worry a little bit about jostling the coil that's in there. And it's just something to worry about. And with LED, you don't have to worry about that at all. You just shut it off and go.
Yeah, and off you go.
So
great stuff, Nick. Thank you very much. That's a great kind of run through of a lot of the cooling technology behind that. So I think that will answer our questions. For those of you out there watching, if this is your first time of watching one of our videos, we thank you for watching, and we ask you to click this. Let's see, we'll put the link right here. We're going to put that subscribe link right here for you, so you can subscribe and not miss any of our shows, because we put different shows up each day of the week, and there's some good stuff out there, and we'd like to have you be part of that. Once again, Nick, thank you very much for your time tonight, and we'll be back again and cover another question in our next show.
Awesome. Thank you, John. Have a great day.
Yep, thank you very much. This is John Young with the Disc Jockey News and Disc Jockey News TV. Thanks for watching. Good night.